Welcome everyone. Hi, I'm Jason Daming. Hopefully I've met some of you before, or hopefully for your robot's sake, maybe you haven't met me. But I'm one of the CSAs here at Championships. I'm also a WPILib team member. I'm here today to present unexplored features of WPILib. So I want to go through some of the corner cases, some of the other things, but it's really all about whatever you guys feel is unexplored. It may be explored by us, it may be explored by some in the room, but I want to do what is most impactful for you guys. So, one of the first things I have here is a little bit of a potential topics. So I've got a lot of different features I can branch into here, but I want to kind of get a feel for the room. I'm going to probably pick 4 of these that I will talk about today. So maybe I'll go through each of these and we'll just do a audible vote. Give me a yay or make a cheer for the topics that you like and that you want to hear presented on. We have a WPILib booth downstairs. I'll be staffing it and along with other members of the group. So please let me know if there are any other topics that we didn't cover. I'd be happy to talk through them. So, without further ado, who wants to hear about simulation?
Yeah.
Okay. Data logging.
Yeah.
Okay. We'll keep going. Timing and memory profile. All right. System characterization.
What is that?
Hey, that's a good. I like the. That's also a good sound that I want to hear. Curiosity. Command Factory API.
I have no clue what that is.
But I like the enthusiasm. All right. Using WPILib with XRP roaming mini robots.
What is that? Yes.
Okay. Network tables 4.
Yeah.
Okay. Triggers.
Yes.
Okay. Some good stuff there. Testing FRC robots. Unit tests.
Yeah.
All right. And debugging. Okay. So I heard a lot of emphasis for these two. I think simulation also had a lot of stuff, and maybe I think if we cover data logging, we can kind of branch that into debugging, and I think those two will kind of go hand in hand for a lot of stuff. That might also allow us to cover an additional topic. So I think simulation is a good place. Let's start there. First off, I'm gonna close these doors. You mind closing that back door there? Just a lot of other traffic going through. People can still, the more the merrier coming on in, but I just want to cut down on the outside noise. Sorry, there we go. So I'll start by talking about simulation. So, how many teams use simulation on the current robot? Okay. Do you use hardware simulation? Or do you use, are you using physics-based simulation or just simulating parts of it? That's okay. So both are available in WPILib. In VS Code, you'll just simply go to your standard, where you control Shift P or the WPILib symbol there. Press that, and that'll allow you to simulate robot code. So that'll launch a simulation window that should be similar to Glass if you've used that, but it'll have its own way that you can run and view outputs of the robot. In order to use this, you really just need a little bit of code on your robot that's specific to simulation. The biggest thing that you need is you still use all of the same regular code that your robot is running, but you need to give the robot an idea of what to do when with its sensors. So its sensors would normally sense the outside world. They'd sense an encoder. It'd sense the robot running along the ground. and they would report back the right outside world data. In simulation, we need to define what that outside data is and how that outside data should be reported back to the robot. In this case, an example would be if we apply motor power, we can assume in a simulated environment that then the wheels would be driven forward at a certain rate and that the encoder would progress at a certain rate, which would then maybe update our odometry or would update other parts of our code. The value here is multifold. When you're simulating the robot, you're able to see the code execution run without actually having the robot. I don't know about most of you, but on my team with my students, we don't get, as programmers, we don't get the robot until a week would be nice before competition, but sometimes it even feels worse than that. So we need to make sure as good as possible that we have code that is going to run on day one. So no program crashes, no, oops, we inverted the logic here. None of those things. We got to just be doing tuning of the robot. So things like PAD and stuff like that are a little bit harder to. Not to say that we can't do physics simulation and tune some of those things, because we absolutely can. But I think the target for most of you that are not simulating right now is, can we simulate the robot so that we can get into a scenario where all of those easily catchable bugs that you get from the first day or few days of debugging, can you bring those bugs forward and pull those into, I found those bugs in simulation? Some of the libraries, so CTRE and WPILib, have built-in simulation support. Some do not. So that's one thing that I'll cover here is, unfortunately, Rev, while they did introduce some basic simulation in 2022, does not really have simulation support. That's not to say that you can't use, so basically mock over their motor controller and use the basic WPILib motor simulation so it will respond with encoder counts and it'll look just like a motor, but if you're trying to do, let's say, like onboards control of your Rev motor, so you're trying to use one of their onboard stuff, you won't be able to really debug that because they don't actually have simulation that makes that motor act as if it was actually on your robot. Limelight also has no simulation support. There's really no good replacement for using the Limelight on your robot and doing that. Photon Vision, on the other hand, is another popular alternative. It does have simulation support. So that can be a really handy feature when you're trying to debug, aiming at the goal or note tracking or other things like that. So you want to get started with simulation. I've linked here, so I'll post all of these the presentation afterwards. I've linked here to the WPILib docs pages where you can see setting up simulation. But basically, you're going to have a sim for most of the WPILib objects. You're going to have a sim object that you'll use all the same way you're using your natural, setting the motor power or whatever to that object. But you will control what that object is getting back from its encoders will be specified by some logic. Like I say, that stuff is already built into a CTRE and some WPILib functions, but you'll have to set that up. Let's see, are there any questions, more specifics you wanted to hear about simulation? Was there more about how to get started, or what really, maybe from you guys, what's preventing you from doing simulations? Is it knowing about it, or?
So I was curious, you need to create like a different type of object for each like motor for simulation, and do you need to have like different logic to handle that?
So when you're so each Each robot's going to be different. But if I take, not many people are doing this anymore, but if you take like a differential drivetrain, for example, when you're setting up that differential drivetrain, we have a simulation object in WPILib that would allow you to simulate that as a differential drivetrain. Now, one of the other things that I get to here is most teams are doing swerve. Unfortunately, swerve is really hard to model from a physics standpoint. Friction is a really complicated thing, especially when you've got turning and that swerve is going. So modeling the swerve drive from a pure physics standpoint is really, really hard. But if you just assume a no friction, light on physics environment, you still get a lot of the same response, the drive of your swerve. It just may not be exactly the same way that you're gonna see on-field performance. So when I was talking earlier about testing your autonomous modes or something, you're still able to see your swerve drive on a field 2D, so you're past your odometry to virtual field. You're still able to see your robot do your autonomous routine and verify it goes through the correct paths and everything like that. But it may not account for, bumps in the carpet, or it may not account for some of the how it interacts with the field, and it may not exactly match the actual trajectory path. Did I?
Thought about that?
Sure.
So one thing that I've found over the years with regards to simulation is that simulation is super. Oh right. So one of the things I found with regards to simulation is that simulation is super useful for semantic testing, right? So like, does my robot do the right motion, right? It's not super useful for, the physics stuff, because the physics stuff is super, super hard, right? So if you're trying to like say, okay, are my autonomous mode things going through the right motions? Like, are those motors moving at this point in my trajectory, right? It's really good for doing that offline without a robot. But without super complete physics, like you aren't going to get like real things, but that's okay, right? Because if you can get it working semantically, logically correct, then you can just tune it, right, on your real robot.
And to his point, I think a lot of your other, so like button testing is a common thing that you're setting up, especially early on in your programming. You can, in simulation, verify, you hook up a controller to your computer, you press the A button, do I see the intake go on? You can even simulate, one of your sensors got tripped. Do I see the intake go off? Do I see the intake rise? Do I see whatever you're expecting to happen there? You can verify that all of that logic is actually passing through and is being executed in simulation. So you would see the motor voltage go up. You would see encoder counts start to read. But yeah.
I was just wondering, is there a way to combine hardware and simulation? Like, if you want to test your hardware in combination with simulation?
Not built into this side of simulation that I can think of. The closest thing that I can think of with that is you can actually run your robot in simulation, but have a limelight hooked up to your robot, hooked up to your computer, hooked up to your network. And if you set up your computer correctly, and this is deeper than I really wanted to go on this, but you can get the robot simulation to actually use and find your limelight and detect tags and stuff like that. So now you actually have your limelight that's detecting tags that then can actually update your odometry. So I have tags centered around my office, and I can change the limelight, and it'll actually update the odometry that will think I'm at a different place on the field, even though I'm just sitting in my office chair.
So security has some limited support for talking to hardware performance.
Okay. Apparently C-Terry does have some support for talking to hardware. I am not aware of that, and I have not delved into that. But you guys know more about?
Yeah, with the CAN board.
Oh, with the CAN board.
We're going to support that you plug the CAN board into the laptop.
Okay. That might be real interesting to look into. That seems interesting. I haven't explored that. What's up?
So does Photon Vision support simulations?
So Photon Vision does support simulation. Keep in mind there are a bunch of physical properties that you kind of have to lay out and you have to specify. So they have, you'll load up and you will kind of by default get all the like April tag positions.
Yeah.
But you kind of have to set the properties and the physical qualities of like your camera. So different cameras may have different qualities. And so you want to say basically, assume my camera is perfect from a distance of 10 feet. And then it would treat in simulation like you got a perfect image, you got a perfect odometry from that thing. And you can even enter in noise and there's some other things like that. But you kind of have to set up some of those physical properties that it's modeling about, so how it responds.
So you could use it for testing best case versus worst case scenarios, basically.
Yes, you can use that, but Limelight does not, other than the kind of hardware in simulation thing that I mentioned, doesn't really have that option. I don't have a lot of time here, so I'm gonna move on to data logging. So if I had to pick one thing that all of you should be doing coming out of this meeting, it is by far this. I kind of say that a little bit biased because I'm an orange hat and I want to help you be your best team on the field. But the number of teams that I come up to, and I'm talking even world-class, like Einstein-winning teams, and they say, you know, I was on the field and my robot did this. And we're like, well, we can look through your driver station logs, but really that only tells a part of the story. It kind of only tells what your driver station, what information your robot has reported back to your driver station, and some of the print logging that your driver station will do, which is really an incomplete picture of your robot's activities. So WPILib has data logging that is very comprehensive. All of network tables can be logged with a simple one-line command here. That will give you a very high amount of data that really informs about what your robot was doing during the match. So just one line of code can enable a lot of that log.
Do you put that robot in it?
Yes, normally robot init or one of those initialization parts. Yeah, go ahead. I'll kind of get.
I'm just wondering if this has any conflicts with like Advantage Kit.
So Advantage Kit is a different type of logging, but it's similar in a lot of ways. If you're already doing Advantage Kit, then really this isn't for you. I'm not saying you're not doing good things. You're doing great things. You're logging a whole bunch. Advantage Kit is data logging on steroids, on taking to the extreme, and that's great. I fully support all of that. But Advantage Kit, in order to use Advantage Kit, and just I want to speak to the larger audience here. Advantage Kit is a way of replaying data back through your code so that you can analyze what happened with the actual data as it runs through your code, and even make changes to your code and replay that data through. This is not that. That is a lot more complicated. It requires a lot more changes to your code and everything like that. This is just logging the state of your robot as it's going on the field.
Is the log like a clear text thing, or
So yeah, it's the WPI log format. You can view that in several different applications. We bundled Advantage Scope this year. That is probably the #1 tool that I would use to view the log. It'll also allow you to download that log off of your robot and view, graph, chart, all kinds of great stuff that you want to do there. Is there anything that data logging does? No, I don't think so. I mean, so the premise of Advantage Kit is log everything. And that is really what it does. And it tries to log all of the input and even output parameters of every single subsystem and motor. We're not going that crazy. I'm not saying that you can't and there's no reason there, but That's the far end of the spectrum here. I really just want to get the vast majority of teams to be logging anything. When I go up to a team and so like talking with a world-class team that I was talking to recently, and they tell me, okay, we're running an autonomous, I tell you 5 seconds in, our elevator wouldn't work. Okay, were your buttons working? Was the motor disconnected? So there's a lot of different things that could be. But if I have logging, now I can see, oh, joystick inputs were actually getting to your robot code. If I have logging from a hardware side, I can actually see, oh, your motor controller was actually getting a signal saying, I want you to go to X voltage, but maybe a cable wasn't plugged, or maybe, so I've got a lot more data points along that, other than just driver station logs. I got a lot more data points along that troubleshooting process that I can look at to tell what actually went wrong. It's really unfortunate to tell a team, something went wrong, but I don't know how to tell you what it is without kind of trying to guess and look at your robot and try to reconstruct that. Maybe it's a software thing, but without the data, it's really hard to make that inference. One thing you gotta be careful about here is the more data logging you're doing, the more space that fills up. The RoboRio 1 is not a workhorse. It's a little guy, especially when it comes to storage space and memory. So we're mostly talking about storage space here. The RoboRio 2 has that external storage, so it will generally be a little bit more okay. With the RoboRio 1, you'll definitely want to plug in a flash drive as some extra space for that. You can also log joystick data. That can be very helpful for troubleshooting. When you're talking about, so I mentioned logging to NT. I think for the vast majority of teams, all those times that you're doing that print statement, you're trying to debug your code, you're just printing data out. One, that's extremely slow. And two, you have no record of that data other than that flowing through your terminal window or looking back at driver station logs. That's not a good way to debug your robot. Please don't do it. If you were instead to take that line, that print line, and just write that data value to NT and be logging that data, now you can take that data back and using Glass or using Advantage Scope, you can look at that data, you can trend that data, you can graph that data and see how it changes over time. And that's a lot easier to make inferences from than these print statements that are gonna bog down your code and that are gonna really just also make it a lot harder for us CSAs when we go to try to figure out where and when your robot dropped. We're gonna be parsing through this driver station log. If you're printing, every robot loop, that makes it near impossible to sort through all of that stuff. But in addition to logging directly to network tables, which will then be picked up by our logging software to actually be logged, you can log directly to the data log. And monolog is one tool. A similar tool or that tool may become part of WPILib in the near future. But it's a tool that's an annotation-based logger where you specify in a simple way, you specify, hey, I want to log this, or I want to log part of this subsystem. And it will automatically send that data off to the log. It doesn't need to send it out to network tables, so it's a little bit more efficient that way, and you can log even more things. That's where we're talking, get in with the image and stuff. Yes?
So is that implementation as well control a lot like Eli Barnett?
OBlog, yeah. So, yes. Yeah, so he collaborated on Monolog. He built OBlog, which was before that. That was kind of what Monolog was based on. It added additional features. Eli is was a member of WPILib. I'd say he is. He does enough work that he still is constantly contributing to different things. Any other, yeah?
Why don't you enable logging by default? CTR doesn't view user stuff.
So I can't speak for the whole team, but my general impression and the biggest argument I've heard is that there's still a significant number of teams on the RoboRio 1. And as I said, the RoboRio 1 fills the log really, really fast. And it can create a bunch of space concerns for that. And while I think that data would be really useful for those low resource teams, we don't have a good way of still supporting them without filling up their drive. I think that, I'm just speculating here, but I think that in a future hardware revision of what's the next control system, I would expect, maybe not exactly this, but some sort of logging to be enabled by default, where those type of concerns aren't really the same.
Could you just do it for like the first flash drive plugged in? Because I believe that's what CTR does.
Do it to a flash drive plugged in?
Yeah, so like if they look for a,
Well, so you're basically saying don't do it if there's not a flash drive.
yeah.
Ah,
So I think that's what they do. Like if you have a flash drive plugged in, on,
both,
otherwise they don't.
both CTRE.
Well, you have to, if you, it's by default if you initialize it or CTR.
Are you talking about boot logging? Because that's not.
Anyway, it's just that.
Okay. Yeah, I mean, I think we all, I'm speaking for the team here. I think we all agree that we want more logging. We just got to do that in a safe way that recognizes the limitations of the lowest resource teams. And if there's any way that we can do that, I think we're on board. That was a good segue into CAN signal logging, which I think is a similar but also simple topic. So you mentioned CTRE. So they have what's called a hoot log. Basically, this is logging the actual data coming from the CAN bus, the individual motors and devices on the CAN bus. This is similarly simple. They have documentation to enable a one-line thing of log all my motors. This will also create a high amount of logs files, so you'll still want to have the same precautions as far as USB drives and other things like that. But this is the actual motor data received by CTRE and the actual CAN inputs and outputs. So this data is really useful for things like system characterization. That was one that I don't think we'll get to today, but that gives you an idea of what the motor is doing at the lowest level, and if it's happening there, that's a good ground truth data on what the motor is seeing in order to execute its actions. If you talk to CTRE, what they're going to want for debugging your problem is one of these hoot logs. That's their number one troubleshooting tool for support, is that log. Rev is in a little bit different spot in that they don't have an official tool. Jonah, one of the WPILib developers and one of the very helpful members here, has designed Urkel, which is a replacement for Rev's tool. It will allow you to do the same feature, injecting those Rev keys directly into network tables, which can then be picked up by the data logger. But this is another feature that is easily enabled at very low cost. Now, a lot of people think, oh, I'm logging all of this data to my RoboRio. I'm already memory constrained and I'm already processor constrained as it is. Like, this is just gonna break the back. In a word, that's just not true. This is heavily optimized to use as little resources as possible, and the vast majority of situations I've seen, this is not the straw that's even in competition for breaking the camel's back. There are lots of other things that teams can do to shave off both that loop timing and that total CPU usage to do things. So when you're cutting things, I wouldn't first assume it's this. I would check all of your other timing and profiling, other concerns like that.
What things would you suggest checking?
For what?
For the
Okay. I'm glad you asked. That is right. Actually, you know what? Let's talk about timing and memory profiling. So, you're getting loop overrun errors, you're getting out of memory errors. If you're getting one of these two things, the first thing I would do before you go through all of this complicated, in-depth on Rio debugging, I would take some basic steps here. So let's talk about timing specifically. Calling configuration periodically or repeatedly. So a lot of teams will have, a periodic section, and they'll be calling the, putting their motor into a voltage mode, or they'll be calling setting their PID parameters or something like that. All those things are meant to be called once at the initialization side of things, and for the most part left. Some of those can be updated in code, but those will be pretty costly to do in a loop. I see this especially with very new teams using looping, so that the whole robot program is naturally looping. So if you're doing some sort of while loop or something that you're getting yourself stuck into, that's an easy cause for loop overruns and other things like that. The lastly is just not good programming practice in terms of where you're spending your time. And I think in a lot of ways, using command-based will help your team kind of do this right. And then instead of you having this very long periodic structure where you're running through this giant loop and checking all of these things, instead you're running commands using triggers, and you're doing these actions when your robot gets outside stimulus, and less of like this periodic polling of everything under the sun and then doing actions, and more kind of independent separation of concerns. Not saying that you can't do robot code successfully in a time-based manner. You absolutely can. But I'm just saying you need to be a little bit more careful about how you're going through that robot code periodically. For memory, that's one that a lot of teams have run into, especially this year. I think that a lot of teams are doing more and more. Path Planner is becoming nearly ubiquitous across the FRC spectrum. And teams want to have 100 different autonomous routines that they all generate at the beginning. And I'm not signaling out any one thing, but we're doing more and more, and our resources haven't changed in, I don't know, how long has Rio 1 been out? Too long. But so haven't changed in a very long time. So I think you're seeing a lot more teams run into that this year. Asking, do I have a constant or increasing memory problem? So there's a lot of things that, let's say you're making an array and you're just adding and adding and adding to that array. Now it's probably not that simple that you're just adding to an array, but there are things that you can do on a periodic basis that you're not clearing, that you're not releasing, that you're just winding up a bunch of references that can lead to this ever increasing memory problem. But I think recently a lot of teams have run into just I'm doing too much stuff problem. And especially on the Rio 1. And from what I found from being a CSA and everything, that disabling the system web server is a big help in the right direction. Now, if you have an ever increasing memory problem that's just spiraling out of control, this may push you a little bit further down the road, but you're eventually still gonna run into that problem. You're still growing memory. But if the solution is you just can't fit all the stuff you want to do in the memory that you have. This is one tool. Doing periodic, so I'm speaking mostly to the Java crowd here because this is mostly Java stuff. Yeah, but 85% of FIRST is Java, so I think that's a good crowd to speak to. But doing Java garbage collection periodically is one good way to more consistently maintain the memory required to keep your robot running. It doesn't let the system control that and actually do the memory cleanup at an inopportune or late timing. So let's assume that you've done all those things. And once again, both of these links here are to FRC docs pages where you can view the actual WPILib docs on these subjects. Nothing I'm telling you here, almost nothing I'm telling you here is revolutionary. This is all documented. If you dive down the rabbit hole of the WPILib docs, please do. Please let us know if something you learned here is not on the docs, because that's something we want to make available for every team and make easily understood. So you can use a program called Visual VM to do the actual memory profiling here. So once again, we have a step-by-step guide on FRC docs. But basically, this is something that Visual VM is a tool you'll run on your laptop, but you will run with some Gradle changes and a few program changes. You'll run code on your robot that will allow you to get some basic timing information and also potentially get a heat dump that you can look at later. With these two things, you'll be able to diagnose both those memory and those timing issues. From the memory side, one thing I think that trips people up is even the basic robot code has a significant number of memory objects that it just has to create by default. We've got a sample output of that basic memory map on this WPILib docs guide. And I found comparing that, basic robot program to your robot program can really help you highlight the differences between the two and where those memory problems are coming from. On the timing side, so this allows you to drill down into what's taking the longest in your robot code. I found that just using and really inspecting the timing warning that you're getting on that printout can oftentimes at least point you in the right direction of finding this issue before you even have to delve this deep into the problem. It'll point you to a certain subsystem, it'll point you to a certain call or VI that you're doing. If it's just like your main or your periodic or something, that's where it can be a little bit trickier. The biggest things I would look for is those things that you're doing in a periodic fashion that might be blocking or that might be taking a significant period of time. Yes, Kevin?
Same thing you said on memory is true for timing. Like compared to a blank robot program, there's a
100%.
whole random WPILib that's going to spend a lot of time and wait for notifier, and that's not a problem. That's waiting.
Yeah, that's absolutely okay, and that's completely normal.
So same thing, just compare.
But if you're
like
spending
a blank program, if you're suspicious of something, and it's also doing it in a blank program, that's the way it's designed.
Yeah, hopefully it's not doing loop overruns in a blank program. If you've got that, you've got a different program.
If you're
But
at the profiling step,
exactly,
same thing for timing as you were talking about for memory. Compare and look for what's different.
100% agree. Any other questions that kind of answer your question about handling memory and CPU usage, stuff like that? Okay, I'm gonna skip all the way down to debugging. So I already mentioned a little bit about print statements. I'm gonna call a second thing here. If I have a second thing that first thing, do data logging. log some data, both your CAN data and your network tables data. Please log that data. Please look at that data. So that's another thing that I find that some teams, they'll turn on this logger. Have you ever looked at the data? No. Well, how are you learning about what your program is doing and where it's spending its time? Or you think that your targeting is working right, but maybe it's off or you've got some problem. If you're investigating this data, then you can try to find those issues. I would be pulling, after each of my matches, I would be pulling that data off your robot, and that's what your programmer can be doing between matches, is they're looking at all driver station logs, they're looking at they're looking at data logs, they're looking at CAN logs, and they're seeing, hey, is there anything that we were doing that we weren't expecting? Now, Jonah's got a presentation on Advantage Kit for those that touch that. If you really feel like you've been doing data logging already, you've got data logging under control, and you want to take data logging to the max, I'd recommend that. That's the next step in your data logging journey, but I think that's a lot more complicated than what I'm.
Absolutely, but really, that's going to be on the first website, right?
Oh yes, both the video and the presentation are going to be on Chief Delphi. So not the first website, nothing affiliated with First, but it will be posted.
Thank you. Thank you so
so
much. Have a great day.
Yeah, thank you. Don't use print statements. It'll make both of our lives easier. If you have one when you're starting different sections of your code, that's not gonna break the internet. But if you're consistently debugging your code by injecting print statements in different places, I would contend that there's a better way. You could even doing that exact same thing, but instead logging it to network tables and analyzing the data log, or using a program like Glass to see those network table values as it's running, is just as easy as printing, but you also have the full look back and the full introspection of the entire history of that signal. Whereas if you're logging to print, you're looking at data, you're either trying to catch it live or you're looking at your driver station logs and you've got it in this big mess of stuff there. I already touched on a bunch of this, but mention this to a CSA. If you're having problems, mention it to a CSA if you have data logging. Because a lot of us, some of us will ask, but a lot of us will assume that driver station is kind of the best we have to work with. But if you have this extra data, there's a lot of help that we can give you by looking at the data and trying to understand and interpret that data. And like I said, it helps us narrow down. And when I say us, I mean me and you, us working in collaboration to try to figure out this problem. A lot more to help diagnose the problem. This also helps, I see a lot of teams that'll be like, oh, I wasn't sent the right driver station, the right alliance color. I wasn't sent this from the, a lot of these problems where the team was saying, oh, my program acted differently than it has been in the past. I want to replay. Well, we really have no information on if it was just your code or if something actually happened. I mean, I think we can be the first ones to admit that things do happen. But in order for us to really figure out what happened, to be sure what happened, we need to have the logs and the stuff to back that up. And there is almost no case where if it's a coding issue that we're gonna say, yeah, you gotta, and I say I don't make any decisions on replay. That the FTA is gonna say, yeah, you gotta replay because your code did something funny and we don't really know what happened. No, that's not gonna happen. But if you can say, okay, here is all of my logging, here is why I was seeing these high trip times, here is why I was seeing this problem and this problem. Now we've got data that we can actually have a conversation about how we fix this problem and how we move forward. But it's only with that data that we can actually have that. So I had a little problem with my switching the presentations from my Mac to this PC here, because this is all I had. So I don't have much, I don't have this slide completed here. But you can do debugging on your robot. So once again, you go to the WPILib icon there and select that, and debug robot is one of your options. This allows you to step through your code, debugging your code on your robot. Now, you have to be very careful with this. Use this tool very, very carefully, because you can run into things like if you tell the robot to go and then you hit a print statement, you hit a breakpoint in your code, you've got potential for I don't want to say runaway robot, because that's not, but understand that when you break in your, come to a breakpoint in your robot, that can affect the overall execution of everything else that happens after that point. But what you're really using this for is more, you're breaking at a specific point in your code to understand what the current state of your robot is at that point, so that you can manipulate that state or change that state and then make future adjustments from it. I wouldn't say, oh, I can pause my code here, resume it, pause my code somewhere else and resume it, and kind of expect everything to operate the same way. I would use this to try to get in and try to understand what is specifically happening at a specific point in my code. Yeah? Would an e-stop work? So e-stop is always available. E-stop is in at the hardware level. So this is why we harp on using the first software and only using the first software and not going outside of the first ecosystem for anything that you're doing robot controls wise, is because it's built into the system that you cannot get around these kind of safety controls. It will always work even if you do something, I don't want to say something ignorant in your program. You'll always have those controls to rely upon. You can't crash your program in a way that's going to allow your robot to run away uncontrolled. You're always going to have that safety stuff to fall back. And that's really important. A lot of people will ask me, oh, this RoboRio is a piece of junk. It costs thousands of dollars and all these other things. There's a lot of safety components built in there where it's really hard to get that replication if you just ran your robot off of a Raspberry Pi. It's not really the same thing in that option. Did I answer the question, everything? I need doing on time here. Oh, we are right about at time. So let's more open floor for questions. So you can find me and multiple other WPILib members that are around the room on both Chief Delphi and Discord. If you're not on Discord, I'd highly recommend that you join. Especially for programming, you've got a large community of people that are, I don't want to say just sitting around waiting to answer your questions, but there's something that's like nearly invaluable about I'm running into a problem, I'm getting instant feedback. Sending an email to X vendor and getting a reply 3 days later is just not a real way of working. Getting an instant reply from one of the most knowledgeable volunteers in the entire FRC ecosystem. I'm not talking about myself, by the way. I'm talking about a Volunteer of the Year award winner in the back of the presentation. But so having someone like that be available in chat or something like that is really, really invaluable. But it's not just those people, it's everyone else who's built up the knowledge. And hopefully you can help someone else in that same position debug or fix their problems. We have a booth down in the Innovation Fair. There are a lot of topics I couldn't cover today. 45 minutes is way too, Innovation Fair, sorry. Robot Service Center. I don't know why I said Innovation Fair. Robot Service Center. We're down next to Rev and next to all the CSAs, so you just look for a bunch of orange hats and you're in the right spot. come see us, come talk to me or one of the other members about any of the other topics. I'm sure we'd love to talk your ear off about it. Slides will be posted to Chief Delphi. We're always looking for more contributors. There's nothing special about what I or any of the other members do. We're not, we don't get paid by FIRST. We weren't duly anointed by anybody. We just saw a problem and fixed it and kept fixing problems. I think a lot of you probably do the same thing on your own team. It may be even a problem in WPILib. Please, one, tell us about the problem. That's a great first step. If we know about the problem, that's something that we can fix. Two, if you've got a solution to a problem, just upload that code or share something about that in some way so that we can try to build off of your effort. Now, I can't guarantee that we'll use it. We might completely throw it away and do it in a different direction. So no promises, but at least you've started the conversation, and just you starting the conversation is a big step in the right direction to fixing any of these problems. Lastly, I've got my email up here. I've got some business cards if you want to email me something separate. So I'm love to talk about this stuff, and come find me. All right, see ya.